Good morning everyone and welcome to today's webinar. My name is Keira Proctor and I'm the Managing Director here at the Proctor Group, and this is the 9th in our series of webinars. If you've missed any since we started these back in April, you can go back and review all of them on our YouTube channel or on our website at www.proctorgroup.com. Today we're going to be discussing advanced membranes in offsite housing, a topic we know very well here at the Proctor Group. We've been involved with the timber frame industry since we launched our FrameShield 100 breathable membrane back in the 1980s. Although timber frame was a major part of the construction sector up here in Scotland, the past 30 years we've seen its use becoming more widespread across the UK and the technology involved get ever more advanced. Not only has the traditional timber frame kit of the 1980s evolved to meet increasingly challenging efficiency requirements, but the offsite construction sector has expanded to encompass a variety of innovative types of structure, collectively referred to as modern methods of construction. So, in today's webinar, we're going to give an overview of these construction types and the benefits each can bring to the housing industry. We'll then consider the membrane applications associated with these methods and the roles that they can play in optimising building efficiency and streamlining the construction process. The common thread between the methods of construction we'll discuss today is the use of off-site manufacturing. Moving processes from a site to a factory environment brings several benefits in a range of areas, from improving manufacturing tolerances to minimising waste. In previous webinars, we've discussed the concept of design for manufacturing and assembly, which applies in varying degrees to these methods. The key concepts of DFMA revolve around designing out complexity and minimising the potential for errors, and the more controlled environment offered by factory manufacturing makes a lot of this easier to achieve. As everyone involved in construction knows all too well, building sites are busy environments, with many processes interacting under often less than optimal conditions, which often necessitates a degree of compromise to get anything done. Weather, unexpected geology, delivery delays affecting critical processes or mechanical breakdowns all have the potential to derail a very well-planned construction process and affect everything from timescales to budgets. The more processes that take place under controlled conditions, the less potential there is for this kind of disruption. The flip side to this efficiency is that more off-site processes limit the ability of the process to adapt to changing conditions or unexpected problems. There can also be issues around factory production capacity, access to site for larger vehicles, or the scalability of processes. All these systems have strengths and weaknesses, and choosing the right structural system to meet project requirements is just as an important specification decision as insulation levels or membrane specifications. What's most important is adopting a well-thought-through design process, minimising the potential for issues to arise. This is the original type of off-site timber framing, the classic kit house. These structural panels are partly fabricated in factories, but with a substantial degree of on-site finishing required. The studs and sheathing boards are assembled in the factory, and the panels are fitted with external breathable membranes for weather protection, but the panels are then left open, meaning that insulation, services and internal finishes are installed on site. The studs in this type of panel are the main load-bearing members, transmitting vertical structural loads which the sheathing boards prevent the studs from twisting and moving. The wall panels and floor cassettes are transported to site, then assembled into the structural framework of the building. While this part of the process can happen very quickly, giving a nominally wind and watertight shell, time must then be spent fitting external cladding or brickwork, slating or tiling the roof, and fitting services and insulation into the framework. The big benefit to this type of framing, however, is the availability and capacity both in terms of materials and contractors reducing resilience on single sourcing. Closed panel frames. This type of panel is similar structurally to open panels, but the insulation is generally factory fitted and enclosed with additional sheathing internally. This additional sheathing protects the insulation in transit and can also provide additional structural racking. A common problem when fitting insulation on site is that studs are not always at precisely correct spacings or vary according to panel dimensions, openings or structural requirements. This can result in insulation boards being cut to fit on site, which can't always be done precisely enough to limit convection around the board. Because the insulation is factory fitted in this type of frame, it can be installed to tighter tolerances with less potential for unwanted air movement around the insulation boards. This convection can lead to reduced performance due to higher than anticipated air leakage, or to condensation problems if the vapour tightness of the insulation is being relied upon to provide a vapour control function. These panels are transported and erected on site in the same manner as open panel systems, but services are typically installed using internal batten spaces, which can further bring air tightness benefits. In a cross-laminated timber panel, softwood timber planks, typically 30 to 40 mm thick, are glued together to form solid panels. An odd number of layers are glued together at right angles to each other and bonded together under pressure to form solid structural timber panels, similar to large, thick sheets of plywood. The panels can then be fitted with a vapour permeable membrane to protect them during transit to site and limit the amount of pre-completion moisture within the panels. They can also be left uncovered, with membranes added after the layers of insulation later in the construction process. These panels can in theory be any size and shape, but in practice, manufacturing and transportation considerations tend to limit the size to around 3 metres by 16 metres. The alternating timber layers give the panels excellent structural properties, and being solid, joints can be made at any point. Openings for doors and windows can be placed anywhere in the panels, but along with the general layout and structural design of the building, this must be fixed at the point of manufacture and cannot be changed later. Once the panels are manufactured and delivered, the on-site erection process proceeds extremely quickly. However, should any changes or alterations be required at this stage, the delays and cost increases can be considerable. CLT panels only form the structure of the building. All insulation, cladding and services must be added after the panels are erected. While this adds time to the process, it does allow a high level of flexibility in terms of varying performance and aesthetics between structurally identical buildings. Because the panel properties can be varied and optimised to fit more or less any strength or spanning requirements, the CLT is commonly used to build high-rise structures as well as houses, with the world's tallest timber building, a mixed-use development in Norway, coming in at 10 stories and 85.4 metres in height. CLT systems also score very highly as regards to sustainability, panels being fully recyclable and wastage being minimalised. This is offset somewhat by the limited UK manufacturing capacity, however, with more panels being sourced from mainland Europe and transported. Structural insulated panel systems are similar in their basic concept to CLT panels, but place insulation within the panels. A typical insulated panel comprises of timber sheets, usually OSB, sandwiching a core of rigid foam insulation. As with CLT construction, these panels are manufactured in factories before delivery and assembly on site, so locations of doors and windows and the layout are fixed in place. But because the panels are pre-insulated, there is less work to be done on site. Because the panels are not bridged by any less insulating structural material such as stud-work, they can match the thermal performance of traditional timber frame walls with substantially less thickness. A panel of around 140 mm thickness can comfortably meet a U value of below 0.2 watts per metre squared Kelvin, while a typical open panel timber frame with site-fitted fibre insulation would only achieve around 0.3 in the same thickness. In common with CLT though, there is scope for problems to arrive if project requirements are not fixed and tolerances on site are not achieved. SIP systems also rely on the use of blown foams and manufacture timber products, so may not always align with project requirements if a more ecologically focused build method is required. The last option we'll consider today is using volumetric construction methods, where building panels are assembled into completed modules in the factory. They are then transported to site and assembled into the final building configuration. In this type of construction, the modules can be pre-fitted with all the services required, and depending on the final cladding choices, can even be pre-clad, requiring only the junctions between models to be completed on site. This method fulfills many of the ideals of design for manufacture and assembly, by minimising the number of different components involved in the build process, and is therefore ideally suited to buildings such as hotels or student accommodation, where a large number of repeating features are required. That said, it's becoming increasingly common to see these methods used in housing. In these applications, it can be easier to achieve enhanced energy performance by reducing air leakage using modular buildings, while the time required on site can be minimised. This can allow housing developments to be completed on site more quickly and to a higher standard than could ordinarily be achieved in that time frame using traditional methods. As with CLT though, there can be issues with bottlenecks in the supply chain and scalability owing to the relative newness of this type of construction and a correspondingly lower number of suppliers. It is also very difficult to accommodate late changes and adjustments without substantial cost and time penalties. Another particular challenge for architects when using modular construction in housing is to avoid uniformity and repetition in design. Careful consideration of cladding choices and building layouts is therefore necessary. With increases in production capacity, building this way has the potential to not only increase the rate of construction to meet the ever-increasing demands for housing, but may also go some way to mitigate the challenges posed by social distancing on sites going forward. By limiting the necessity for concurrent processes, an assembly line approach to construction can better facilitate the need to maintain physical separation between staff. An important advantage in the short to medium term, and one present to some degree in all forms of off-site construction. So, what role do construction membranes have to play in this way of building? In order to design structures that are energy efficient and healthy to live and work in, designers have a clear need to balance the heat, air and moisture movement throughout the building envelope. By either permitting or restricting the passage of air and/or water vapour, construction membranes play a vital role in managing and controlling these interactions. By providing more reliable and consistent hygrothermal performance than, for example, brickwork or timber, construction membranes allow a more precise degree of control over these processes. The building regulations typically address condensation moisture in the same sections as damp and moisture ingress from other sources. In the UK and Ireland, that means Part C for England and Wales, Section 3 in Scotland and Part F in the Republic of Ireland. Northern Ireland is also Part C, but it's a different document from that applying to England and Wales. As regards to controlling the condensation, the relevant clauses in all these regulations refer the specifier to BS 5250, the Code of Practice for the Control of Condensation in Buildings. This means that wherever in the UK or Ireland a building is, the applicable design principles in terms of minimising the effects of condensation are more or less the same. In terms of construction membranes, BS 5250 gives technical definitions for each type of construction membrane. Air Vapour Control Layer, AVCL. Continuous layer of impermeable material. This simple definition is actually not as helpful as those given in the previous issues of BS 5250, which defined air and vapour barrier functions separately. The older definitions are therefore worth considering. Airtight layer. A layer which prevents the convective movement of air under the normal pressure differences found in buildings and which may also act as a vapour control layer. It should be noted, though, that acting as a vapour control layer is not a requirement for airtight layers. Air permeability and vapour permeability are two independent properties. Vapour control layer. A vapour control layer is defined as a material of construction that substantially reduces the water vapour transfer through any building element in which it is incorporated by limiting both vapour diffusion and air movement. The addition of air movement to this definition means that all vapour control layers function as an air barrier. However, there is an important caveat. To be fully effective, an air barrier has to be fully sealed and continuous. While this is an important consideration regarding vapour transfer too, there is a little more margin for error before a badly sealed VCL will create condensation problems. Poor air barrier performance, however, will impact the building energy performance calculations and is subject to pre-completion testing. Breather membrane. Membrane with a vapour resistance of less than or equal to 0.6 meganewton-seconds per gram. It's probably more accurate to refer to breather membranes as being vapour permeable rather than breathable, as this helps avoid any confusion associated with the air and vapour permeability of the material. The BS 5250 definition currently concerns only the passage of vapour, so membranes can be either airtight or air open. This is something that's likely to be addressed in the upcoming revision of BS 5250, which, as we've discussed before, was due this year but now may be delayed due to the pandemic. We'll keep you updated as soon as anything changes though. The property referenced in BS 5250 is vapour resistance, with a value of less than 0.6 meganewton-seconds per gram, required to meet the classification criteria. It is, however, increasingly common to measure membrane performance using SD values, in which case a value of 0.12 metres or less would be required. An SD value, also referred to as a vapour diffusion thickness, or air equivalent thickness, is simply a measure of the thickness of an air layer that would be required to resist vapour transfer to the same degree. Type HR and LR underlays. The term used prior, breather membrane, is more usually associated with wall applications. Membranes used on roofs typically require more vapour permeability. BS 5250 defines two classes of roof underlay, type HR high resistance and type LR low resistance, with 0.25 meganewton-seconds per gram or ST 0.05 metre being the cut-off between the two. LR membranes can be specified without roof ventilation if that application is covered by current third-party certification, while HR membrane will typically require ventilation in all circumstances. LR membranes, which are also air open, will typically have fewer restrictions and exemptions applied to non-ventilated use. To illustrate the way we can use construction membranes to counteract the harmful effects of moisture, we'll consider a typical domestic timber frame wall built using an open panel construction. This type of wall usually consists of structural timber stud-work with a sheathing board or OSB, or plywood supplying racking strength. The principles of membrane use apply similarly to all the construction types we've discussed, however. Breathable membranes are installed on the cold side of the structure, and today nearly all vapour-permeable membranes are manufactured from either polyethylene or polypropylene. The microscopic structure of these membranes is such that they contain many small and narrow pathways. These are large enough to allow moisture vapour to pass through, but not sufficiently open enough to allow liquid water through. Additionally, many such membranes contain hydrophobic additives, making the surface of the membrane actively repel liquid water. In the simplest terms, the primary function of a vapour-permeable membrane is to provide weather protection to the structure during transportation and construction, and then to remain moisture neutral once the building is complete. Once the timber structure is completed, it may be some time before outer brickwork and roof tiling can be completed. The key performance criteria for such membranes are therefore water tightness and vapour permeability. Test methods for vapour-permeable membranes are laid out in EN 13859 Parts 1 and 2. Part 1 covers roofing applications, while Part 2 relates to walls. Weather tightness is tested to EN 1928 for W1 and EN 13111 for W2. W2 is usually sufficient for wall applications, while for roofing W1 is required. Water vapour resistance, if greater than or equal to an SD value of 0.2 metres, should be to EN 1931. If below 0.2 metres, it should be tested to ISO 12572. In this application, we would typically suggest our frame-type membrane, which provides simple and cost-effective secondary weather protection in applications where no specialist performance characteristics, such as air tightness or fire ratings, are required. Vapour control layers are fitted on the warm side of the construction, usually directly over the stud-work behind the internal lining. They are typically made of reinforced polyethylene or a laminate of aluminium and polyethylene. Because they are designed to be as impermeable as possible, vapour control layers can fulfil the function of limiting air leakage, but if they are to be used in this way, good detailing and installation are very important. The primary function of a vapour control layer is to reduce the quantity of moisture vapour entering the building fabric. By ensuring the water vapour remains in the heated spaces of the building, it can be removed by planned ventilation systems, as well as an installed vapour control layer can prevent this vapour reaching cold surfaces where it can condense into liquid water and cause damage. In order to do this effectively, the performance of the vapour control layer must be matched to the building's intended use. Structures like warehouses with large open areas and frequently opened external doors are defined as being low risk and as such require less resistant vapour control layers. At the other end of the risk scale, swimming pools and gyms typically experience far higher moisture vapour loadings and require correspondingly higher vapour barrier performance. In the middle of the scale, applications such as homes, offices and schools are classed as being medium risk. In all cases, ensuring the integrity of the vapour control layer is maintained is very important. Any rips and tears or puncture damage to the membrane will provide a path for moisture vapour ingress. Heavier, reinforced membranes are therefore preferable, as not only is damage less likely to occur, but it is also less likely to spread across the membrane surface than with unreinforced membranes. We can supply a range of vapour control layers with performance characteristics to meet almost any project requirement. ProCheck 125 and 300 membranes provide lightweight, cost-effective performance for low-risk applications, while the heavier ProCheck 500 membrane covers the majority of medium-risk cases, where no special characteristics are required. For high-risk applications, the Profile 861 material uses an aluminium core to boost vapour resistance, while a durable polyethylene coating provides corrosion resistance for use in chlorine-heavy environments such as swimming pools. The upper surface is also coated blue to reduce glare when working on site. As the building regulations demand ever-increasing energy efficiency from all areas of building design, the use of construction membranes to boost thermal performance has become more prevalent. By utilising high-performance, low-emissivity coatings to restrict heat flow, reflective construction membranes allow the thermal performance of timber frame walls to be enhanced with little or no increase in thickness. On the outside of the timber frame, the standard vapour permeable membrane can be upgraded with a reflective outer surface in order to boost the thermal performance of the wall. Reflective breather membranes retain the characteristics of standard breather membranes, so offer good vapour permeability and weather tightness, but utilise a property called surface emissivity to reduce the heat flow out of the building. Low emissivity or low E surfaces limit the ability of a material to emit heat via infrared radiation, similarly to a foil survival blanket. In order to do this, the proportion of heat transfer by radiation should be maximised by introducing an adjacent airspace. In timber frame walls, this adjacent cavity is already present, so the low emissivity surface can reduce the U value of the wall with no increase in wall thickness. By simply switching the specification to a reflective membrane, wall U values can be improved with no other changes to the building specification, which makes this a simple change to incorporate into existing designs. The same reflective principle can be applied to vapour control layers internally. When used in this application, however, the requirement for an adjacent airspace means that an additional void must be provided to ensure radiative heat transfer is maximised. In practice, this is usually achieved by introducing a service void by adding additional battens over the studs. This void not only ensures the reflective vapour control layer can work effectively, but also allows installation of service runs into the wall without puncturing the air vapour-tight layer. This reduction in penetrations helps improve the effectiveness of this layer and can help simplify the installation of building services. The thermal resistance of a standard airspace of more than 19 mm in a wall is 0.18 meters squared Kelvin per watt. However, when using reflective membranes, this increases substantially. The A. Proctor group has two reflective membranes, the Reflector-Shield TF breathable membrane and Reflectotherm Plus vapour control layer. The thermal performance of both of these membranes has been hotbox tested to ensure an accurate reflection of in-service performance. The Reflector-Shield TF increases the thermal resistance of the outer cavity from 0.18 to 0.81, while internally Reflectotherm Plus has a cavity R value of 0.78. Both of these values represent significant improvements over non-reflective cavity resistances. This table shows some example U values that are achieved when using our reflective materials. As can be seen in the table, depending on the specific construction used, the use of reflective membranes can mean the difference between compliance with regulations or not. These values are based on a typical brick-clad timber frame wall with either 89, 115 or 140 mm depth studs, using a 15% timber bridging fraction and either mineral fibre insulation at 040 or 035 thermal conductivity, or 022 rigid foam. We offer project U-value calculations among our range of technical services, so for specific advice you can get in touch at technical@proctorgroup.com or by online chat at www.proctorgroup.com. Following many years of increasing insulation requirements, further improvements in that area are both impractical and economically unrealistic, leaving air leakage reduction as the most effective pathway to future progress. In buildings, air leakage is the uncontrolled flow of air through gaps and cracks in the building envelope. If this flow is not adequately controlled, it can significantly impact the energy performance of a structure, and if used correctly, construction membranes can play an important role. One of the most recent construction membrane developments is the use of external air barrier membranes like wrap-tight and frame-tight, which represent a significant departure from accepted traditional practice. Traditionally, the vapour control layer, being inherently airtight, has also performed the function of the airtight layer in the construction. While this solution does work, it places a lot of emphasis on the quality of installation and sealing of the membrane, which can be difficult and time-consuming. Moving the air barrier to the outside of the building, away from the services zone, means there are far fewer potential penetrations to the air barrier, and there is no requirement for expensive specialist components such as airtight junction boxes, light switches, or downlighter hoods, for example. Airtightness is an abstract concept referring to the building's ability to restrict unplanned air movement, but it is not a directly measurable property. It's important not to use unclear language such as low airtightness, as this could be easily misunderstood. The air leakage rate is a measure of the rate that air can escape from a pressurised building envelope. It's expressed in metres cubed per metre square per hour. So, cubic metres of air escaping per square metre of the building floor per hour, and it's usually measured at a pressure of 50 pascals. When we talk about an air tightness of 3, for example, this is the figure we mean, so to avoid confusion it's preferable to refer to an air leakage rate of 3. To further complicate the issue, air permeability is the figure used to express air barrier performance. In most cases, an air barrier membrane will be 0, or as close to 0 as to not matter, so this should not be taken to imply any effect on the air leakage performance of the building as a whole. The wrap-tight air barrier membrane is designed to adhere to the external face of the timber frame panels to provide an effective and robust barrier to the movement of air. By moving the airtight layer externally, wrap-tight greatly simplifies the installation of building services internally, as less account must be taken of penetrations. The mechanical durability of wrap-tight, further enhanced by being fully bonded to the substrate, ensures the air barrier layer can be factory installed and transported to site whilst maintaining its integrity. Being highly weather resistant with a W1 rating, the membrane provides effective temporary weather protection as well as ensuring the building meets its designed air leakage rate targets, reducing the likelihood of expensive and time-consuming remediation. Although moving the air barrier layer externally represents a more dependable solution to minimising air leakage, control of vapour movement by diffusion is still important and must be carefully considered and managed if necessary. At the same time, it should be ensured that structures are able to dry out effectively in all conditions, and in such cases, variable vapour control layers such as our ProCheck Adapt have an important role to play in highly airtight constructions. As homes become increasingly better insulated, more airtight and more energy efficient, effective management of moisture becomes ever more critical. An important factor in efficiently managing the year-round flow of moisture in buildings is ensuring that systems and fabric can modify their behaviour to account for changing circumstances. ProCheck Adapt varies its vapour resistance in response to environmental conditions, meaning its resistance to the passage of water vapour increases in winter to block the ingress of moisture into structures when internal vapour pressure is at its highest. Correspondingly, its resistance lowers over the drier summer months, allowing the warmer temperatures and lower moisture loadings to dry the structure out, ensuring a healthy environment is maintained year-round. This means the building fabric is protected from damaging moisture levels during cold, wet months of the year, and it will allow the fabric to dry out effectively in warmer, drier months. ProCheck Adapt's translucent structure eases fixing to structural frames, and in conjunction with the integral tape allows for a fast installation time. Combining the external air performance of the wrap-tight membrane with the flexible internal resistance of the ProCheck Adapt provides a double layer of air resistance to reduce air leakage rates, whilst ensuring an optimum transfer of construction moisture in any direction. While fabric insulation is effective in reducing heat loss from the building envelope, as insulation's levels increase, its effectiveness per unit thickness begin to drop off. This is because the thermal transmittance or U value of a construction is the inverse of its thermal resistance. What this point means in practice is that boosting insulation levels is only practical and cost-effective up to a point. Beyond that point, we need to consider alternative measures to restrict heat loss from buildings. Minimising air leakage is the most effective additional measure that can be taken to boost thermal performance. The holistic energy performance of dwellings is assessed via SAP calculations, which incorporate the effects of all building fabric and systems on its overall carbon dioxide emissions. In this type of assessment, lowering the air leakage rate from 7 to 1 can give a similar uplift to energy performance to increasing the fabric insulation from 130mm to over 350mm. While this reduction in air leakage sounds dramatic, by using the wrap-tight air barrier membrane, adhered to the external face of the sheathing, and taking care to ensure it is well installed around windows, doors, and sealed to any other penetrations, this is not difficult to achieve in practice. The primary advantage of wrap-tight isn't necessarily improving the airtightness result, but making arriving at that result significantly easier, faster, and less affected by the actions and skills of installers. Modern homes contain a huge variety of different services such as switches, sockets, and TV connections, all of which require cable runs and therefore penetrations through an internal airtight layer. This means that in addition to taking care to ensure these installations are scheduled and detailed such that penetrations through the airtight layer are minimised, specialist proprietary switch boxes and other hardware may be required. As well as potentially increasing costs, the requirement to use such hardware may lead to delays if it is not readily available for purchase. A worse outcome may be the substitution of less well-sealed components with corresponding reduction in performance. External air barriers like wrap-tight offer excellent reliability and consistency. Window, door and pipe penetrations are made airtight in a straightforward manner with our wrap-tight tape or liquid flashing. This simplicity and reliability ensures the air leakage rate is more dependable and repeatable across buildings, which, as we've seen, gives significantly improved design flexibility in other areas such as thermal insulation. Unplanned and uncontrolled air movement, or drafts as we've referred to it for centuries, removes the ability to control and manage the environment. The desired outcome is not the absolute elimination of all air movement and transfer, just of that over which we do not have control. This means design and specification of ventilation systems is important to consider holistically with the fabric insulation and air barrier systems. Any type of ventilation system, from fully passive to a fully active system with heat recovery, can be made to work effectively at any design air leakage provided it is designed in early enough. Buildings are never too airtight or too leaky, they are out with their design specification. Any air leakage rate can be accommodated depending on what other trade-offs or compromises are made. Systems like wrap-tight help to ensure low design air leakage rates can be dependably achieved on site, reducing the need to either undertake remedial action to fix leaky building fabric or introduce additional ventilation to compensate for as-built performance not meeting the design criteria. Another important role for construction membranes in today's building is limiting the development of spread of fire within buildings and in cavities. On the outside of the heated envelope, fire-resistant vapour-permeable membranes can play an important part in limiting fire spread in facades and also in restricting the spread of flames between adjacent buildings. They can also provide important temporary fire protection during construction periods, particularly important in large-scale timber frame construction. The key property in fire resistance is the EN 13501 fire classification, also known as Euroclass. This classification is primarily required by building regulations when used at over 18 metres in height, or 11 metres in Scotland, reflecting the particular importance of controlling fire spread in high-rise applications. It is, however, becoming more common to specify fire-resistant membranes in low-rise applications, going beyond the regulations. In addition to offering good vapour permeability, weather resistance and air barrier performance, The fire shield membrane uses a unique intumescent surface composition to actively restrict the development of flame. It achieves a Class B S1D0 fire rating. However, in practice, its performance in response to fire development is dramatically different. As can be seen here in this comparative test, the Class B membrane on the right shrinks away and does not contribute to the fire's development. However, the fire shield on the left remains in place, with its coating protecting the substrate from ignition. This test was conducted by the University of Edinburgh and is based on the EN 13823 Single Burning Item Test. It was conducted as part of the process for inclusion in the Structural Timber Association product papers for their FR build specification. Internally, fire-resistant vapour control layers play an important role in preventing the development of fire in internal spaces, and also in limiting transfer of those fires to the outer layers of facades. This is in addition to preventing the ingress of moisture vapour and reducing air leakage. ProCheck A2 is a laminated glass fibre and foil composition protected by a clear lacquer. This gives ProCheck A2 a unique additional benefit of a low emissivity surface, which when used with the service cavity can enhance the overall thermal performance of the construction, as well as providing high fire performance with its A2S1D0 fire classification. ProCheck FR200 is used as a fire retardant vapour control layer in roof and wall structures in new build and renovation projects. ProCheck FR200 has a reaction to fire classification of BS1D0, which provides assurance of fire performance for the structure. The ProCheck FR200 air and vapour type membrane also improves energy efficiency and reduces the condensation risk. Used together, these fire-resistant membranes can provide an easily applied solution to boosting fire protection of the building fabric and limiting dangerous fire spread across all areas of the structure, from inside to outside. Particularly in high-rise or flatted developments, ensuring fire spread is as restricted as much as possible, and the protective measures are reliable and durable is a critical part of the overall design strategy. We covered fire performance in a lot more detail on our previous webinar, so if it's of particular interest, you can go back and view that on our YouTube channel or at www.proctorgroup.com. So that concludes our overview of membrane applications, and we'll now move on to your questions. Good morning, everyone. Thank you very much for joining our 9th webinar, believe it or not. When we began these lockdown webinars, I think we were hoping that we'd do a weekly one, sort of 3 or 4. But of course, because of the circumstances we find ourselves in, we have done a lot more. So welcome, I hope you're all well and that you're taking care. Just quickly, if you enjoyed the webinar, please give us a thumbs up. And if you'd like to subscribe to our channel, you can do that on YouTube there. As you know, we'll try our best to answer all your questions. We have had quite a lot through email already, and I can see some more coming through on the YouTube chat. So stay on as short time or as long as you like. We will get round to them all. One thing that's slightly different for those that have attended our previous webinars, we've updated the webinar page on our website. So there is a link to it in the YouTube feed. But if you go to www.proctorgroup.com/webinar, that's where you can find the links and the downloads to download your CPD certificate for today's webinar and any prior that you've done. You can actually register now for our next webinar, which is in 2 weeks, which I'll come on to in a moment. And there's also other actions that you can do within that web page. So you can request a meeting with one of our technical staff, maybe one that's on this page, for example, that's going to be on this chat today. We can organise to go through CAD details with you for your particular project. You can request a sample literature pack specific to the membranes we've discussed on this webinar, and a couple of other options. So please take time to peruse it and see if there's anything you would like to do. We love getting your feedback. So after this, you will receive an email with a link to a replay, which you can circulate to colleagues or others who may find it of interest. And there will be a link to a feedback survey. I read all the feedback, we action and we take it on board. Sometimes there's comments in there, with things we can help out with. So again, I tend to email back, or others in the business do, to help. So if you have time, we would really appreciate it. So the webinar in 2 weeks is passive house and low energy housing design. Really interesting one, quite ironic because I actually built a low energy house and moved in 2 weeks ago this week. So it's something I know a little bit about and the trials and tribulations of building to low energy. And it's very informative. So I think we'll be using it at my house as a case study, which is encouraging me to use the time lapse that my husband and I did. So we'll have all that information for you again, along with quite an educational webinar about these type of house builds and Passivhaus. Okay, so I'm conscious the webinar was slightly longer than usual, so I'll get round to the introductions. A couple of new faces this week. So we have Ian Fairnington, who is our technical director at the Proctor Group, has been for a very long time. Carol Mikulak is our project coordinator, who she manages tracking all the projects we're working on, linking with specifiers and architects and helping them with their requirements and helping the team on that side of things. And most people will hopefully have met Sue and Mark by now. Sue Menmuir has been in our technical department for, again, a long number of years. So becoming quite a familiar face now. And Mark Lambourne, a long history in the construction sector, had a career previously with Proctor, and we managed to talk him into coming back to work for us last year, which was great to have him back on board, so a wealth of knowledge. Okay, so that's it. I think we'll just start with the questions. I'm hoping the mics are unmiked, if I can just double check that, and we'll get started. So Sue, if I can start with you, if that's okay. James has asked, is a vapor control layer always needed? Or I think Sue's just, oh shoot, Sue's back, great. Sue, is a vapor control layer always needed, or can I exclude this cost? No, Sue's not on mic, just bear with me 1 second. This shows the challenges of live webinars. There we go, she's back. Great. Sue, did you get the question?
Yes, I did. It's not necessarily always a requirement. It will depend on a few aspects, what the rest of the construction is, what the internal conditions are in the building. And it'll also depend on whether you're relying on your vapor control layer to act as your air tightness layer as well. So depending on all these conditions, we obviously have a range of membranes that can suit. We have a range of vapor control layers for use in low-risk applications, high-risk applications, and also where you need a little bit of breathability as well. You would maybe go for the ProCheck Adapt. If the vapor control layer is not necessary for the vapor control aspect, which we can check using condensation risk analysis or RIFI analysis, you have the easy option of going for the wrap type membrane externally, which will also provide you air tightness.
Okay, that's great. And Sue, one that's kind of on a similar strain from Jack, is a vapor control layer always airtight? Is there any more you want to add to that?
Typically they will be airtight, and that's down to the materials that they're actually made from. These membranes are generally typically made from polyethylene or aluminium foil, which by their nature will be airtight anyway. Obviously, the weak points will be the jointing of the membrane, any punctures, penetrations, etc. through there. So all that will combine as to, and workmanship as well, as how airtight your vapor control layer is.
Okay, thanks, Sue. Morning, Ian. Come to you for a couple. Morning. So one that's been posted on YouTube, again, quite relevant to what Sue was asking there. Simon Wilson-Jones has asked, can the use of membranes be wrong in some circumstances?
Yeah, morning everyone. Yeah, membranes can be put in the wrong place. They've all got a very good purpose within the structure, but used in the wrong place, there can be a build-up of moisture problems. For example, using a vapor control layer on the wrong side of the insulation. In our climate, the cold side could lead to a build-up of moisture, which could take a long time before it's actually found. Less so with a breather membrane, vapor permeable membrane, used in the wrong place because it's to a certain extent moisture neutral. But certainly you have to be careful. Luckily, the Proctor group have a very good technical team that could work out the correct precision and correct anything that might be misplaced in the wrong place and advise accordingly.
Great, and I was mentioning earlier about the functionalities available on our webinar page, Proctor Group /webinar. That, I believe, one of the functions on there is the condensation control calculation. So if people do have specific project questions, you can go to that link.
Yeah, sorry, I would add to that. Yeah, the condensation risk, that's a very good point. But if you need an additional condensation risk, we do have the ability to do WIFI calculations, which can take the condensation that bit further.
Absolutely, great. And that's a topic we've covered on some of our prior webinars. If people want more information, you can go back and look at that, or email us and we can discuss it with you. Yeah. Great, okay, Ian, while we've got you, we'll pick on you as a new face. I hear that, sorry, Callum, this question is from, I hear that intelligent membranes are the way forward and we should be using them.
Yeah, intelligent membranes, we discussed during the presentation there, passive adapt membranes can be used. And in the passive house regulations or requirements, recommendations, they do use intelligent membranes on the inside as the vapor control layer. They have got a good use. Their dynamic nature allows the vapor to open and close as required. So it can be a useful addition to a construction, in particular in breathing walls. And they have a potential use in solid walls, where there's always the problem with solid walls, existing solid walls, and allowing the structure to dry out. So intelligent membranes have their place, and again, the Proctor Group can advise on the right place and right time to use them.
Yeah, I think as well they are a bit more mainstream. They've been around for a while, so I think this concept of them being new is perhaps not quite right. They have been around for a number of years now, so it's not a new concept. So tried and tested, and something we can help with. Okay, great. Mark, if I can come to you for another one we've had on the YouTube feed, please. So Simon has asked, what third-party accreditation does Raptite hold for modular and off-site construction, and what support and design services do we offer?
Right, okay, morning everyone. Well, Raptite is specified or has BBA certification really for 3 areas for off-site construction. So we've got BBA certification for the wall, modular floor cassette construction, and warm non-ventilated roof, so in fully supported applications. It's also assessed and been certified by the LABC and Premier Guarantee, so it's got their warranty approval, and the membrane is currently included in 2 BOPAS accredited systems as well. So in terms of the technical support services that we offer, we've got obviously U-value calculations, condensation risk analysis, as Ian was talking about, and the more detailed hydrothermal assessment. So as Ian suggested, the WUFI calculations. So that really depends on the placement of the insulation, etc. And we can go into that in more detail if you get into contact. In terms of the other type of support that we offer, our external teams at the moment are offering virtual meetings, so through the Zoom or Microsoft Teams meetings. And from that, we can do design and detailing advice and installation training and that type of thing.
Great. Okay. Thank you very much, Mark. Just to address them very quickly, Structure Boys asked on the YouTube feed what the effect of fire is. So that's quite a general question, Structure Boys. So thank you for that. If you look on the YouTube channel, 2 weeks ago, we did a particular webinar on fire solutions. So that's available to view. So if you want to view that again, or contact us about any particular questions on fire, because it varies depending on the membrane, the structure, the substrate, the project, but we'd be happy to help. So if you want to watch that, or contact us, webinar@proctorgroup.com. Okay, perfect. Carol, welcome, first webinar. So Carol has asked, actually, I didn't pick this one for any particular reason, another Carol's asked, I've attended a number of your webinars during lockdown, very useful, thanks a lot, that's great. Is it possible to arrange virtual meetings to discuss projects in more detail? So obviously Mark clarified that we do. Have you got anything to add on that? Because you're quite instrumental in organising these meetings. So.
Yes, sure. Good morning, everyone. Most definitely, you can get in touch with us on the website, proctorgroup.com. You can select a division from the Market Sector tab and click on where it says Book a Zoom presentation. As Mark said earlier, we can arrange a virtual CPD with one of our specification team, or alternatively, we can do a video meeting where we can use the share screen function. Now, that's quite handy so we can look at project drawings, assist with the detailing, and discuss all our products and services in more detail. If this is something that you are interested in, please just give us a call, make a request via email, or select a specific product and book a meeting from there. All the usual communication channels, and we'll be in touch.
Okay, that's great. Thank you very much, Carol. Sue, if I can come back to you, please. Just have a look here. James has asked, I do not have a service cavity. Can I still use a reflective vapor control layer?
Okay. Yes, in principle, you can use it. It will still function as a vapor control layer. Typically, a reflective vapor control layer will be manufactured using a foil. So therefore, the actual vapor resistance is usually really quite good anyway. However, good practice would be to install a service cavity, because what that does is it prevents a lot of punctures into the membrane, a lot of weak points, which obviously then will detract from the performance. So yes, it can be used as a vapor control layer, but regardless of the vapor control layer that you're using, a service cavity would be good practice.
Okay, that's great. Thank you, Sue. Mark, if I can come back to you, please. Paul's asked, what membrane is best suited for warm pitched roof and room in the roof application? So we are seeing more warm roofs in the UK, so a good topical question.
Yeah, warm roofs are really sort of commonplace within Europe, and they offer really good weather protection. So they provide a dry and usable loft space and use traditional really trades and materials, so slate and tile and that type of thing. So we are a bit slow to change in the UK. We like to build like my dad and my granddad, and that's the way we like to build. But we're slowly getting there. We're starting to employ warm roof construction. So it's good to see that that's being used, and we're enhancing those same roof designs to manufacture or produce these warm roof constructions. So for fully supported applications, Wrap-Tite's really the way to go, fully self-adhered membrane, and it's BBA, as I said earlier, certified for warm roof non-ventilated construction where it's fully supported, and it can accept a range of roof finishes, and it offers a number of benefits. Obviously primarily improved air tightness, but also excellent protection from wind-driven rain, etc., because it's fully sealed, all the laps are sealed. It can eliminate the drumming effect, which can be a problem with some of the lighter weight mechanical fixed membranes. If you've got a room in the roof, you can sometimes hear that these lightweight membranes, sort of the drumming effect of those. And it's got a very good low vapor resistance, so easily allows for the passage of water vapor. Perhaps where you've got a warm roof construction, but it's a hybrid warm roof construction, perhaps where the insulation is perhaps 50 mil below the top of the rafter line there, then I guess Roof Shield will be best suited for that type of application. And certainly Roof Shield has been BBA certified, I think, from 1996. So it's long, well established for that type of construction. And has often been employed actually in remedial works where the contractor has installed a lightweight, low resistant underlay. And as I said, it's kept the building owner awake at night, because literally what happens is you get this drumming effect where the membrane is set into this sort of drumming effect pattern light, and that's all you hear at night. So what's happened is that the primary roof covering has had to be removed, and a heavier weight product such as Roof Shield at 185 grams will prevent that drumming effect from happening. So there's really two choices with regard to the type of warm roof construction you're dealing with.
Okay, that's great. Thank you very much, Mark. Another application one, but on the wall side from Rashid. Our preference is for site-applied mechanically fixed breather membrane for our closed panel wall system. So that's what they're currently using. Is a more robust wall membrane available?
Yeah, well, I guess in terms of robustness, they're talking about looking for perhaps a high level of water resistance and improved air tightness. So we've got a product called Frame Tight, which is a 3-layer airtight film laminate. So it's a vapor permeable but airtight membrane and has a class W1 water resistance rather than the traditional class W2 for typical wall membranes in timber frame construction, for example. So it's BBA certified for a variety of construction types, including those in offsite and timber frame construction. And the way this is installed is exactly the same as a traditional mechanically fixed membrane. But with regard to the laps, we use a wrap-tight tape to seal all the laps and any penetrations and like that. So this offers a more thermally efficient, robust system overall, and helps to reduce any issues or problems where there's a failure perhaps to meet as designed air tightness levels. So a good example of that, I guess, would be the guys at BT Passivhaus. So these guys will use the frame tight system to help achieve this high level of air tightness. So these guys are achieving actually air tightness levels of 0.6, so well below 1, and using the frame tight as part of their strategy, if you like, to meet these low air tightness values.
Good. Okay, excellent. Ian, Anne has said, I'm looking at CLT as an option. Which membranes are best suited to control my worry of moisture?
Good question. CLT, it's encouraging to see people starting to use more. It has a good function. You've got, with using CLT, there's a number of factors you need to take into consideration, and one of them is moisture, and obviously Keira Proctor Group are well versed in dealing with moisture. So wrap-tight is a very good option when you're looking at CLT. From a transportation point of view, from keeping it waterproof during construction, minimising the amount of moisture getting into that CLT during construction can be very useful with the wrap-tight, especially with its self-adhered properties. Then when the construction is fully built, then the structure can still dry, and there's a continual drying out of that CLT. So wrap-tight can be a perfect choice when you're looking at CLT.
Okay, that's great. Thank you very much, Ian. David has also asked on the YouTube feed, how do these material solutions change for an LSF structure, so light steel frame? Is that one you can answer, Ian?
Yeah, sorry, what was the question again?
How do these material solutions change for a light steel frame structure?
Yeah, it's great to have so many different questions on different aspects of the building industry. So the light steel frame structure wouldn't be a great deal of difference in terms of where you place the membranes. How you place them might be slightly different, might be more difficult to staple onto a light gauge steel, but the actual placement of it, so you have the vapor permeable membrane on the external side of the insulation, the vapor control layer, if it's required, as Susan said, sometimes it's not, on the warm side. So the application of it in light steel would be in the same way as we've got in our brochures and on our website. Again, we can advise on the right application. Sometimes with light gauge, they have insulation on the outside as well as in between the studs. That can be a really good option because that can reduce the condensation risk even further by placing the insulation further outside the structure. So yeah, we can advise on that one and assess whether you need that vapor control layer on the inside or not.
Okay, that's great. Thank you very much. So if I can come to you, I'm just going to try and go through some more on the YouTube feed, and I've got a couple more via email. So if anyone has any additional, please on YouTube or email us webinar@proctorgroup.com. So Jake has asked you, what effect will service batten fixings have on the air permeability of an airtight membrane? And is there a way to secure a service batten without puncturing the air membrane?
Okay. Generally, there's no way to fix a vapor control layer without using mechanical fixings. So your service cavity batten will always be mechanically fixed through the membrane into the structure. What you can do to limit the effect of these punctures is apply a double-sided tape to the stud behind initially. When you fix through to that, it creates a wee seal around the fixing. As an additional measure, a strip of the foil tape over the fixing line as well will also reduce the effect that that actual mechanical fix is made on the integrity of the membrane.
Okay, perfect. Thank you, Sue. One from Joe. So Carol, if I can come to you, I'd like to propose the self-adhered membrane to a client and prepare a mock-up wall panel. Excuse me. Is it possible to receive sample material?
Okay. For this specific requirement, I'd recommend that you would contact us following the webinar so that we can discuss your particular options in more detail. We do have sample rolls of Raptite available, 1.5 metre by 10 metre, but you also need to consider the accessories for use as well, these including the preformed corners for the window openings, the liquid flashing, and also possibly tape as well. We look at each request for sample material on its own merits. This helps us to understand the proposed construction, what technical services we can offer, and your projected volumes. From there, we can then provide the level of support with regards to the free material. You can also request sample packs, as was mentioned earlier, following the presentation on the webinar page, or again through all your usual communication channels on specific products that you're interested in. But yeah, no problem.
Okay, lovely. Thank you very much, Carol. Mark, we've not spoken to you for a while. So Thierry, I think, has asked, lightweight metal roof tiles provide a number of advantages for our modular buildings. How can we best reduce the risk of condensation in our cold risk designs?
Okay, well, LR underlays are typically used in cold roof designs to provide that secondary barrier to the ingress of rain, wind and snow. And obviously they also allow for the passage of water vapour. That's one of the primary functions. But it's important to consider with all roof types, consider the primary roof covering and think about how air and vapour permeable or air and vapour open it is. So with metal roof tile systems, these are very close fitting and uniform and actually provide a sealed roof system. So when the water vapour is passing through the construction, through the vapour permeable underlay, it then hits this sealed roof system and you can get interstitial condensation forming then, which will drop back down on the membrane and run down to the gutter, etc. So you really need to think about ventilating and two options there. I guess really you want to look at ventilating at low and at high level to create the stack effect, to draw the moisture out. So that could be within the batten cavity, so below the primary roof covering and above the membrane. So you'd use a counter batten to allow that ventilation to go through. So once the water vapours pass through the membrane, it can then be taken out through to outside atmosphere. Or the other option is to traditionally ventilate the roof space. That might be more problematic because of the depth of the insulation, perhaps at ceiling level. But that's another way of doing it, and again that will create a stack effect and draw the moisture out through the top there, through the ridge. So there's two sort of approaches, but with metal roof systems you really need to consider ventilation as well.
Okay, great, Mark, thank you. Another question, and we're just sort of rounding up to the last 4 or 5 now. So Aaron has asked Mark, an external self-adhered air barrier membrane installed onto our SIPS panels in the factory would simplify our design. But how do you seal these panels on site to ensure airtightness?
There's 2 approaches really. We've got the standard tape, which is available in standard widths of 75, 100 and 150 mil. But we can also cut the standard 1.5 metre roll down to say 300 or 400 mil wide if you want to use that approach. The other way is to use a product what we call split liner. So it's effectively a wide tape. And down the centre, we've split the release liner. So what that allows you to do, if I can dig out a sample of the membrane, is the release liner on the back of the tape will actually be cut down the centre there. So this allows you to pull and remove the release liner off the back of the membrane and stick it, say, on the bottom of the panel in the factory, and then you can use this and just take that up out the way. So, for example, if we're dropping one modular unit on top of the other, when you bring this down onto site, you can then bring that membrane down, take up the release liner there, and that will stick and provide the air tightness at that level there. So that can be done horizontally or vertically. So really two approaches, and what you really want to do if you've got an exposed leading edge is to use the wrap tight liquid flashing just to seal that off and prevent any moisture from tracking down the back there. But it's a great way of detailing it, applying that tape in the factory, and then allowing for the detailing on site.
Great. I love how you always have props, Mark. Your office is like Mary Poppins handbags. Just
I'm just fixing Debbie McGee.
Good. Ian, I've got 2 or 3 for you in a row, if that's okay. One from YouTube, first of all. Sean has asked, is wrap tight too effective in regards to air testing in housing?
Okay, I saw that question coming in. I was trying to look around the room, see if there was any props I could use to try and illustrate this. Unfortunately not. I looked at a plastic bag at one stage, but maybe not. Yeah, it's a good question. It's a question that the housing industry do ask us on a regular basis. I'm not too sure about using wrap tight because it could be too tight. The difficulty with that one is it's wrap tight and its use and air tightness is all insulation measures. So can you put too much insulation in your house is a difficult question to answer, and the answer is probably not. So can you make it too airtight? Probably not. You could use it inappropriately and you haven't accounted for the airtightness is more the case. So if you account for the airtightness at the early stage and design for a very airtight, good airtightness building, then your building cannot be too airtight. And that's where the design is very important at the early stages. Decide that you're going to make this building an energy efficient one, and therefore airtightness will definitely be one of the measures you'll take into consideration. And therefore you've got to account for that and make sure you have air movement as required. The moisture side of things will be taken care of by membranes, but the air movement you've got to keep going. And if you account for that at the early stages, you can't make it too airtight.
Good. Okay, and that's something we'll probably be covering in 2 weeks in a lot more detail. Air movement, air tightness, and how that is linked with energy efficiency and insulation values in our Passivhaus and low energy webinar in 2 weeks. So if people are interested, that would be a good one to join on that topic.
Good one.
Ian, Derek has asked, I understand that reflective membranes can increase the R value of associated cavities and thereby reducing U values. But what else can I use to improve the energy efficiency of the building?
That follows on very well from the question we dealt with just recently on the air tightness. Yeah. The easiest way or the best way to improve your energy efficiency, as said in the seminar, is to reduce your air leakage. So wrap tight and products like that, or vapor control layers inside, the adapt membrane, are good examples of how you improve the air tightness without having to go to extreme levels of insulation. And we are looking at that, and a lot of builders are looking at that as to the best way forward. As the government strive for better insulation values, it doesn't always have to be a thickness of insulation. You can change the membrane and effectively provide a much more energy efficient envelope.
Mm-hmm. Good. Okay, another one which is talking about thermal performance of reflective if branded. So Carol, good one for you. Are we able, from Josh, sorry, are we able to produce own branded membranes, and what effect will this have on the thermal performance of reflective wall membranes?
Well, yes, custom artwork printing is available. It's available on our Frame Shield 100, the Reflective Shield TF, and our frame type membranes. You can have up to 3 colours on any one artwork. And the colours that are available are black, white, blue, red and green. Now, if it's just a simple outline design that you're wanting, The custom printing on reflects your TF membrane. It will not affect the thermal performance on the low emissivity surface. However, if you are looking for a more solid coloured printing or a bit of a complex pattern, then your thermal performance, it can be lower than it would be on standard material. My suggestion for this would be contact us with any proposed logo or design that you've got. We can process the artwork to meet a specific thermal performance, or we can calculate what thermal resistance it is following the procession of this artwork. So yeah, we can look into that for you, no problem.
Good. So people probably have seen branded or companies with logos on their buildings and they wouldn't know it was a Proctor membrane. So we do a lot of own branding for our customers. So it's great to promote, their brand or your brand if it's something you're thinking of. It's free advertising if you like, and you're pretty sure that the right product's going up on your building. So. Okay, 2 questions left. I'm not seeing any other coming through. So the last 2 questions. Graham has asked, Sue, we've not spoken to you for a while, and how long can your membranes be left exposed? So very topical at the moment. So we were asked this a couple of weeks ago in one of our webinars. Great. Due to lockdown, a lot of projects are sitting with membranes exposed longer than what manufacturers recommend. So I have a project which has been sitting since lockdown with the external leaf exposed.
Yeah, as you say, we're being asked this quite regularly at the moment. Typically, we would say, obviously, it's good practice to ensure that the membrane is covered as soon as possible, certainly within at least 3 months. That's for most of our membranes. Luckily, however, we did embark on a testing programme last year where we actually set out our membranes fully exposed outside for up to a year. Every 3 months they were samples were sent off to an independent laboratory, and what we found is after the 12 months the performance of the membranes in terms of the vapour permeability, the air tightness, they were not affected. So that does give a wee bit of confidence that once covered the membranes will perform as they are intended to. Ideally, obviously, you would need to check the membrane, just look for mechanical damage. The longer a membrane is exposed, it does become more susceptible to mechanical damage, but anything like that can be quite easily either patched or repaired before the external leaf goes up.
Okay, great. And Sue, just sticking with you for one more quickly, you answered a question from Jake earlier about the internal vapour controller being penetrated when it comes to the service cavity. He's asked, does Raptite suffer the same issues with puncturing by the external batten fixings? Let me start with too many questions. Batten fixings to support cladding and or brick ties.
Okay, the Raptite is, obviously any mechanical fix through the membrane has a potential to, affect the performance. However, the Raptite is manufactured using polypropylene, which generally, when that is punctured, it doesn't actually split, it just moves the fibres apart, which then create a wee seal around the fixing. It's also adhesive as well, so that adhesive on the back side will create a wee bit of a seal as well. If there's a lot of fixings or if there's any little damage or cuts, then we have the liquid flashing, the Raptite liquid flashing, which can just be applied around just for extra precaution.
Okay, that's great. Thank you very much.
Can I add on that one? Sorry, I would agree with you totally, Sue. I mean, a good example of the Raptite performance was the testing we did at Windtech last year, where we tested the air tightness, water holdout of Raptite in a vertical application. And we were very encouraged by the results we got, where the Raptite was installed, then the hanging brass brackets were put on it, screwed through the membrane, and then an air tightness test done. And the air tightness test was very good in terms of the air tightness being unaffected really by the fixings of the hanging brackets. So that was very encouraging that we got that performance. We've also had other testing where the contractors or house builder has actually put fixings through the Raptite and actually put a weight of water on the product, 400 millimeters sitting for 24 hours, and the membrane's not leaked. So difficult to say it's self-sealing, but it's got very good properties for when it's penetrated because of the adhesive and the polypropylene fibres together.
Great, thanks for adding to that, Ian, appreciated. So Ian, the two last questions for you that have come in via email. So one from Gavin, which is quite specific to Profoil 861, which is one of our products, which is a high grade vapor control layer. So he's used 861 in a project, and it's been sealed with 2 strips of butyl tape, but due to poor workmanship, the butyl tape has been missed in a couple of locations. With some condensation, that's resulted in some condensation occurring at the laps. So he's just asking, could the ProCheck 861 have been sealed with surfaces applied tape, allowing better quality control?
Yeah, it's better to use the double-sided tape on the laps, obviously. If it hasn't been done, then the next best thing is to put an overlap tape on it. I think I would rather see photographs of the actual installation to actually comment, but logically, putting the membrane over the laps will help the amount of vapour getting into that structure that will subsequently cool down and subsequently condense. So yeah, it makes sense if it's possible to do.
Yeah, so Gareth, you can email us some photos. We can have a look at those today. So you can send it to webinar@Proctor Group or reception@Proctor Group. They'll both be picked up. So please send it to us and look at them this afternoon. And last question is related to BS 5250, Ian, which is a committee you actually sit on, so appropriate question, of course. Do you have an update on the proposed new BS 5250 controlled condensation code of practice?
Yeah, it's quite a topical one. There's a lot of people asking about BS 5250 and when's it going to be out. I've sit on the 5250 committee. They're never easy committees. They're never quick committees. They take time, and there's quite a lot of robust debates. So the poor BSI tend to think that it's going to be a quick fix when it gets revised, but it never is. But I think we're getting near the end, and there's a hope that it will be out for public comment this summer. When it does go out for public comment, then anybody will be able to comment on it. It's available for 2 months, and hopefully there is some improvements in the standard, looking at moisture rather than just condensation. So it should be a lot more holistic.
Okay, great. Thank you very much, Ian, for that. And thank you to all of you for taking part in the Q&A session. Well done. It's say each week it's not easy to answer questions. You don't know what's coming, so much appreciated. Well done. Thank you very much to everyone who took the time to attend our webinar live today. As I said earlier, you will be receiving an email after this, which will allow you to circulate the replay maybe to staff or colleagues or anyone who you feel may be interested, which can be watched and, as I say, distributed. You can register now for our next webinar, which is in 2 weeks. So if you go to the link in the chat, it's www.proctorgroup.com/webinar. Now on that page, we've added a few different facilities to try and streamline and make it easier for people to request further information or help. So on that page, you can book an online meeting with one of our technical or sales staff. You can leave your feedback, you can request your certificate for this. And as I say, we've added new features where you can actually, we can go through your CAD details with you. You can submit technical drawings, do a condensation calculation or request a CPD. So really this is the master page for everything virtual at the moment. So as a business, we've really diversified quite a lot at the moment and quite quickly, and we're doing an awful lot of virtual and online meetings to help our specifier and customer base. So please feel free to use us and the wider team. So thank you very much indeed. Thank you very much to the team. Well done to our marketing team who worked really hard on these, putting them together, and always impressed with the visuals. And I love seeing the comments on the chat feed. Some old names are recognised, either customers or I see an ex-employee, I see a competitor. We see all types of people coming to these webinars, so it really is appreciated. And the great Q&As always make it a good session and get us as a company thinking about the type of things the market's asking and making sure we have the right answers. So that's it. Enjoy your weekend, and hopefully we will see you 2 weeks today for passive and low energy housing and design. Thanks, guys.
Thanks.